Okay, so for what we have in number 5, we're going to be looking at integrating a linear monomial over a fourth degree polynomial with x all over 81 x to the fourth minus 1. And as we look at partial fraction decomposition, we have, upon factoring, initially we have x all over 9x squared plus 1 quantity times the quantity of 9x squared minus 1. And as we look at factoring, okay, though we cannot factor a sum of squares, we can with the difference of squares, 9x squared minus 1. And so for the ratio, we can factor further to x all over 9x squared plus 1 quantity times the quantity of 3x plus 1 times the quantity of 3x minus 1. And in this resulting ratio, okay, we're going to set up, okay, what we have for the partial fraction decomposition. So for what we have in the case of the original ratio, okay, we have x all over 81x to the fourth minus 1, and considering that we had the 3 denominator factors to result, we're going to have let ax plus b be over 9x squared plus 1. Okay, 9x squared plus 1 again is going to be a quadratic factor, and then we have plus c all over 3x plus 1 and d all over 3x minus 1. And as we look at clearing away the fractions, okay, multiplying everything out by the equivalent of 81x to the fourth minus 1, okay, we have the numerator x. And in terms of mapping, okay, what we have in this layout, okay, now we have for ax plus b, okay, everything is being multiplied by, again, 9x squared, 3x plus 1, and 3x minus 1. 9x squared plus 1 terms are going to cancel. So we have ax plus b quantity times 3x plus 1 times the quantity of 3x minus 1. And c is going to be multiplied by both 9x squared plus 1 and 3x minus 1. And then in the case of d, okay, d is over 3x minus 1. And we will have this to be multiplied by 9x squared plus 1 and 3x plus 1. Alright, now there's going to be a bit of crowding in this particular situation, but for what we have in the development, okay, again we have in the equation, okay, we have x, and once we split up the ax and the b, we have x equal to, once again, a times x times 3x plus 1 times 3x minus 1, and b is going to be multiplied also by 3x plus 1 and 3x minus 1, so we have this collection of statements. And once again, repeating, okay, c is going to be multiplied by both 9x squared plus 1 and 3x minus 1, and d we have, once again, times the quantity of 9x squared plus 1 times the quantity of 3x plus 1. Now we have 3 distinct factors in x from which we can attain real zeros. Okay, and we have, in the group, we have 3x plus 1. No real zeros will result from 9x squared plus 1. But we do have a 0 that can be attained from 3x minus 1, as well as what we had alongside a with the variable x. Okay, and now we have 4 unknowns with a, b, c, and d, and we have only 3 real zeros that we can utilize. Okay, and so for the establishment of, say, the determination of the fourth unknown, we can choose an arbitrary value upon which we can work with x. Okay, so with our equations, okay, we have, okay, from x we have x equal to 0, and from 3x plus 1 we have x equal to negative 1/3, and then from 3x minus 1 we have x equal to 1/3, and then choosing arbitrarily, okay, just and to keep the absolute value as low as possible, we have choosing, okay, x equal to 1. And if you were to plug into this whole system, okay, the values of 0, negative 1/3, positive 1/3, and 1, you're going to have, if x is 0, you have that 0 is equal to 0a minus 1b minus 1c plus 1d. If we had the x is equal to negative 1/3, we had that negative 1/3 is equal to 0a plus 0b minus 4c plus 0d. And for the third and last 0, If x is equal to 1/3, we had that 1/3 is equal to 0a plus 0b plus 0c plus 4d. And then as we substitute 1 for x, okay, we have x equal to 1. And as we plug in 1 for this set of terms, the coefficient alongside a is going to be at 8. Then we're going to have for b, the coefficient is also at 8. And then for c, the coefficient is at 20. And then while x is equal to 1, our d term coefficient is going to be at 40. Okay, and so we have 4 unknowns, we have 4 equations, and now in the setup here we can utilize matrices so as to determine, okay, what the values of a, b, c, and d will become. Okay, and so for lining up our coefficients and setting the equations to from start to finish equal to 0, negative 1/3, 1/3, and positive 1. Okay, we have in this setup, okay, we have a matrix. Okay, that is 4 rows, 5 columns. Okay, so you have these are the a, b, c, and d coefficients, and then you have what the equation is equal to with 0, negative 1/3, equal to 1/3, and equal to 1. And as we look at establishing the reduced row echelon form, okay, we have, say if you were to use your calculator, okay, again, you can go with, okay, the matrix, and some of these calculators might be a second function. If you go to matrix and edit, okay, so you have a 4x5 matrix, and I have already had this set up. Okay, so you have your A column, B column, C column, and then we have the D column with the coefficients, and then again we have the coefficients, okay, upon which each equation is set equal to. You have 0, negative 1/3, positive 1/3, and 1. And as we get out of the matrix screen, okay, we can go back to matrix and then perform the reduced row echelon form, and you can use either the up arrow or down arrow. And I have learned that with the up arrow you can get to your destination a little bit more quickly. Going to command B, where we have RREF, that means the reduced row echelon form, and we're going to go with the matrix. We have enter the numbers for, in this case, matrix A, and as we look at entering, okay, we have this particular set of values, okay, and if you notice we have these decimals laid out, and what I can do is that to clear away the decimals, you can go with the math key, go to fraction, okay, and so for this layout, okay, we have reduced row echelon form, and you have running diagonally these ones running, and for the results here we have going down negative 1/2, 0, 1/12, and 1/12. And so for the reduced row echelon form, okay, what this is going to signify is that we have 1A is equal to negative 1/2, and then we have 1B is equal to 0, 1C is equal to 1/12, and then we have D is equal to 1/12. And now that we have established the reduced row echelon form, okay, what is going to arise in this particular case is that in looking at what we had, okay, for our coefficients, okay, what is going to happen now that we have our values of the coefficients for A, B, C, and D, okay, is that in this particular case, alright, we have, once again, for the layout here, okay, we have, once again, okay, so you have ax plus b over 9x squared plus 1. Again, b is going to be negligible. Okay, and so a is at negative 1/2, so you have negative 1/2 of x over 9x squared plus 1. Okay, and then we have, again, b is negligible, c was at 1/12, so we're looking at 1/12 of 1 over 3x plus 1. And then we have for d, okay, d is going to be at 1/12, and then we have over 3x minus 1, or 1/12 times the quantity of 1 over 3x minus 1. And so in terms of what we have in setting up the integration, okay, we now have for the integral of x all over 81x to the fourth minus 1 dx. Okay, again, we have from a itself, we have negative 1/2, then we integrate all over x over 9x squared plus 1 dx. Again, b was negligible, and in the case of c, we have 1/12 times the integral of 1 over 3x plus 1 dx. And for d, we have 1/12 of 1 over 3x minus 1 dx. And as we look at taking the antiderivatives, okay, so we have for our first term, okay, we have negative 1/2, and then we have the integral of x over 9x squared plus 1 dx, which in this case is going to be considering the substitution. Okay, now the derivative of 9x squared plus 1 goes to 18x, which will cancel out x, but leave us a fraction of 1/18 times the natural logarithm of 9x squared plus 1. Then we have 1/12 times 1/3 of the natural logarithm of 3x plus 1. And then we have for what we had in d, again, was 1/12, and we have times the integral of 1 over 3x minus 1, so we have 1/12 of 1/3 of the natural logarithm of 3x minus 1, followed by the constant, and we have for the final answer in this particular case, alright, we're going to end up with negative 1/36 of the natural logarithm of 9x squared plus 1 plus 1/36 of the natural logarithm of 3x plus 1 plus 1/36 of the natural logarithm of 3x minus 1, followed by the constant. Okay, and so after this very long, arduous process, okay, this is going to be the final answer.